isothermal process. Today we will discuss the other application of first law of thermodynamics, and this is isothermal process. So first we had discussed two of the applications of the first law of thermodynamics. Now we will discuss the third application, and it is the isothermal process. So the isothermal process is that process in which the temperature of the system under consideration is kept constant, or we can say that internal energy of that system is not changing. So as we can see, we can simply write T for the notation of temperature, but when we talk about internal energy, so internal energy is usually written as U, and del U is written as change in internal energy. So hence in this case, when del U is equal to 0, it means that temperature is not changing. Now before we go into other discussion, let me make a few things clear, and these are that heat is being absorbed in this process, but heat is being absorbed in this process in such a way so that it is completely utilized in doing the work rather than increasing the temperature or doing something else, but in doing the work. And last, I want to make it clear that pure isothermal process cannot be achieved. The reason behind this is that there are several frictional losses, some other losses as well, and similarly 100% isolating system cannot be generated. So in contrast to it, an adiabatic process, we will laterly discuss the adiabatic process, where the system exchange no heat. We will discuss it in a later paragraph. So for isothermal process, delta U is equal to 0. Using the first law of thermodynamics, I must have to write that so dq is equal to du plus pdv. It means that heat that is being absorbed is utilized in rising the temperature plus doing the work. Delta U simply refers to the change in temperature. So hence in this case, delta Q is equal to pdv. So in this case, we can write that total heat that is being absorbed is totally utilized in rising in not rising the temperature or internal energy, but it is utilized in doing the work. For ideal gas, only in ideal conditions, I would say. In ideal conditions, delta U is equal to 0, or change in internal energy is 0. So this is the notation for the isothermal process, that it is that process in which the temperature of the system doesn't really change at all. Now we come to adiabatic process. It is that process. Before we go into the slide and discuss it on slide, I just want to make it clear that an adiabatic process is such a process which is completely isolated, and it by no means it exchange any heat with the surrounding. So in thermodynamics, An adiabatic process is a type of thermodynamic process that occurs without transferring heat or mass between the thermodynamic system and its environment. Okay, environment means surrounding. For example, if we have a gas inside a piston, so inside a cylinder having a piston, so this gas or this fluid inside this cylinder is a system, while the other things that are surrounding this piston and glass is just environment. So unlike isothermal process, an adiabatic process transfers energy to the surrounding only as a work. It means that work is being done at the expense or at the loss of internal energy, or internal energy may drop when the work is done. Similarly, when work is done on the system, then internal energy will increase. So, for example, in the first case, the volume of the system will increase and work will be done by the system on the surrounding. In this case, internal energy will be utilized in raising the volume of that system. In the second case, the volume will decrease and the energy or the internal energy will increase. As a key concept in thermodynamics, the adiabatic process supports the theory that explains first law of thermodynamics. Okay, so we come to the first law of thermodynamics. We know that delta Q is equal to delta U plus PdV. So for an adiabatic process, delta Q is equal to 0. It means that there is no exchange of with the surrounding. So in this case, we can see that PdV is equal to minus delta U. It means that work is done, volume will increase, and the internal energy of the system may drop. So in the second case, I can write it as delta U du. We can say I will write the notation as du is equal to minus PdV. There is a great difference between these notations. In the first case, work is being done by the system on the surrounding and the temperature of that system is decreasing. While in the other case, the work is done on the surrounding by the system. That is, volume is decreased, and as a result of that, the internal energy will increase. So that's all about the two topics that we have just discussed. If you have any question, you can write this question in the comment box, and thanks for watching.